another way to say symmetric to the y-axis. So positive x and negative x give you the same answer. Odd is another way of saying symmetric to the origin. So to check that, we were plugging in a negative x and a negative y. The difference is, this is talking about functions. So typically it will be written in f of x notation instead of y. We kind of already touched on this Friday, but could a function be symmetric to the x-axis? No, because if it's symmetric to the x, it would fail the vertical line test. So, if I just asked you, could you tell me if these were even, odd, or neither? So this one, it's symmetric to the y-axis, which means it is even. This one is symmetric to the origin, which means odd. Remember, symmetric to the origin means you would flip over the y and the x-axis, and it would overlap itself. I always just remember the O's go together. Odd is origin. This one, a little harder to tell. Think about if you folded this thing on the y-axis, then this would kind of come here. This piece would go over there. This piece would come over here. And then if I folded it on the x, do those green lines overlap your original? Yes. So if I fold on both the x and the y, it overlaps itself, so that means it is odd origin. What's this one symmetric to? If I fold it on the y-axis, does it overlap itself? If you fold it on both the y and the x, does it overlap itself? Right, if you fold it on the y, it would look like that. Then if you fold on the x, it would overlap that line, wouldn't it? So this one is also odd. Seems like in general we are really good at picking out symmetric to an x or y axis, but it's a little bit harder when you have to think about the origin and you have to think about folding on both of those. I want to look at a couple examples and see if we could do this from the equation. So we can always use our graph to confirm. To do this by the equation, there are a couple options. Since it's written in function notation, even means symmetric to the y, where we did it before. You plug in a negative for your x and see if you get the same thing back. Odd is symmetric to the origin. We plugged in a negative for our x and y and saw if we got the same thing back. If it's written in function notation, all you really have to do is plug in a negative for your x. If you square a negative, it is the positive x squared. So I put in a negative, I got the exact same thing back. So a positive and negative x give me the same answer. So that means this is even. Symmetric to the y-axis, even. Okay, you can graph this thing on your graphing calculator. Go to your y equals, type in x squared minus 5, and look at the graph. when you type that in, you saw it was a parabola just shifted down 5. We didn't even need a calculator for that. That was transformations. So we can tell that it's symmetric to the y-axis, which means even. This one. So if you plug in a negative for your x, if you cube a negative, it remains negative. So this is not what I started with, which means it is not even. To be odd, it has to be the exact opposite of what you started with. Is this the same thing as taking the original times negative 1? No. This one is neither even nor odd. If you think about your transformations, x cubed is a chair. That minus 1 would move it down 1. If you graph this, is that symmetric to anything? No. Alright, for this one, you plug in a negative for your x. A negative cubed is still negative. Minus negative x would make it a plus x. So it's not what I started with, so it's not even. Is it the exact opposite of what I started with? Yes. So that means this one is odd. We couldn't graph this just from transformations, but if you could, go to your graphing calculator if you needed to, and plug that in. So you're graphing the original, 5x cubed minus x. And if you look at that graph, it's similar to a chair function, just gotten a little skinnier, but you can tell that is symmetric to the origin there. So that was why it looked. Any questions? Okay. I have another slide with some more examples of this. Do we need more? I think we've got it. So I told you tomorrow we have a quiz. So the quiz covers section 6 and 7. The good news is that you're really using a lot of stuff in section 7. So section 6 was when I first introduced all the parent functions. So you should be able to graph any of those with a minimum of 3 points by making a t-chart. You should be able to look at those graphs, tell me domain, range, increasing, decreasing, constant. You should be able to graph a piecewise function and evaluate, like if I asked you to evaluate something there. And then this section was all the transformations, and that's what you're working on today, as well as like the even and odd. So that will be the type of stuff on your quiz tomorrow. Are there any questions about that? Okay, so book problems are due tomorrow. You have the rest of class to